Hello and welcome to another lecture of the course Aquaculture. Today we are going to talk about culture methods of ornamental fish species. Culture of ornamental fish species. In this lecture, I will try to give you the example of one freshwater ornamental fish species as well as one marine water ornamental fish species. This is regarding how important these ornamental fishes these days are, and that we have discussed in our previous lecture. So I won't talk about detail of these points. Um, you know, nowadays you can just understand that it is very fast growing market within the aquaculture sector, ornamental fish market that we have talked about earlier in my previous lecture. And people now are keeping the aquaria, glass aquaria, sometimes um, smaller containers, sometimes larger containers. There are variety of materials from which these containers are made. They are being kept uh, in the houses, in your drawing rooms, in your bedrooms, in the offices, in the public places. So popularity of these ornamental fishes is growing, that we all know. In freshwater environments, or in most of the places, if you will see the aquarium, then one fish that you often see, quite common to all the places in many parts of the world, that is goldfish, Carassius auratus. Um, this is we have discussed little bit about this fish also in my previous lecture, that this is one of the most popular fish species because of many variants of goldfish are available now. uh, Beautiful color patterns, then shape of different parts of the body, that is um, very popular. And this fish is supposed to be being cultured since ancient times, when Chinese and other ancient civilizations, they kept this fish in the confined environments, and because of the mutation and other things, natural mutation processes, some colorful varieties came up, and they selected those varieties, and ultimately few more varieties and more varieties came up. Goldfish market alone globally, if you consider, then in 2023 it was 674 million US dollars in 2023. That is good, very good, significant contribution. And it is expected to reach more than 1000, in fact 1110 million dollars by 2031. So the growth rate is very good, that is being anticipated or forecast. There are different varieties, in fact more than 100 varieties of goldfish that are available and very popular in aquarium market. All these varieties originated from the same species, Carassius auratus. Some of the common goldfish varieties are common goldfish, then we have London Shubunkin, Wecken, Taikin, Ruikin, Fantail, Demikin, Tosakin, Comet, Whaletail, Moor, Oranda, Rancho, then Phoenix and Pearl Scale. Now, when we talk of the culture, then we have to keep many things in mind. That if you remember my previous lectures, I told you that whenever to identify a candidate species for culture, always have a good understanding of the basic biology of that particular species or candidate fish species. So we have talked about the biology of goldfish in detail in my previous lecture. So very quickly I will go through this one also, that it belongs to Cyprinidae. We all know this is one of the cyprinids. And there are some these fancy mutated goldfish, and some common goldfish, common variety and fancy variety. Maximum length of fancy type goldfish is about 6 to 8 inches, whereas the normal one may grow up to 14 inches. You know, they can be long living and can survive and grow for a very long age. More than 40 years of age has been reported, as I showed you here. General lifespan is usually 10 to 12 years. Omnivorous fish feeds on a variety of food items, so that is also one of the reasons of its popularity across the globe. Swim at all levels of water in the aquarium, so not so much fuss about where the food should be. This is a very good fish for the community tank because it is compatible to many of these species and it is non-aggressive. So one of the these two are some of the basic criteria for species selection for culture. Breeding of goldfish, maintaining water quality. We all know that water quality provides the optimal ambient environment to the fish for its physiological activities. So that is going to influence the breeding and maturation process. Most important water quality parameters to be maintained in hatcheries are pH, dissolved oxygen, temperature, ammonia, hardness, and alkalinity. The preferable water temperature for growth and culture is 15.5 to 23.6 degrees centigrade. For breeding purpose, the optimal water temperature ranges between 20 to 23 degrees centigrade. It is advisable to maintain the dissolved oxygen at saturation level. Saturation level means if you are providing enough aeration, then dissolved oxygen desired quantity of dissolved oxygen will be there, in fact. And try to monitor dissolved oxygen in such a way that it never comes below 5 ppm or 5 milligram per liter. That is the important criteria. Water pH should be maintained above the neutral level, slightly above, you can say slightly alkaline water is preferred. Total hardness should be greater than 40 ppm as calcium carbonate. And goldfish are very much sensitive to unionized ammonia, and the optimum range is 0.02 to 0.05 ppm in the aquarium. The concentration of nitrite and nitrate should be 0.01 and 20 ppm respectively. Broodstock development. Fishes of 8 to 15 months of age, here, since you are keeping these fishes in the confinement, in the ornamental fish tanks, so the maturation or age at first maturity or the size at first maturity may vary little bit from the natural conditions. So you can observe, and whenever you feel that the fishes are now showing the maturity, and usually the size ranges between 40 to 100 grams. They can be used as broodstock. Feeding of broodstock is being done 3 times per day. We know that we should take care of the broodstock separately, and special care should be there according to their own body requirement. The feeding, the water quality, everything. In the morning and evening feedings, live feeds such as tubifex, earthworm, bloodworm, etc. are recommended, but during the noon, the feeding of formulated diet is advisable. I should again say that it depends on your nutritional and feeding strategy and what kind of feeds you have used to grow the adults and then feeding the broodstock. So whatever works for you, you can go for that, but always remember to provide to meet the nutritional requirement of the fish of that particular stage. Feeding is to be done at the rate of 10% of body weight per day. Of the total ration, 30% to be provided in the morning and evening, and the rest 40% in the afternoon. So that is one of the feeding strategies that has been developed by some researcher. You can based on this, you can have little manipulation at your own site and the kind of conditions that you are having. These are the healthy broodfish which are shown of goldfish, Carassius auratus. These are the characteristics, some of the male and female characteristics that you can notice in case of goldfish. Tubercles on head of the male, operculum, pectoral fins and other fins you can find tubercles. In case of female, it is absent. This is one of the important characteristics in case of goldfish for male and female identification. Abdomen is smaller, slender, may have ridge, but in case of female, swollen belly, as in case of other carps. Large, fatty, circular, no abdominal ridge. Genital opening, long, concave and smaller in case of males, whereas convex, large, protruding outside. That may be the characteristic shown by female. Pectoral fin, edge thicker and pointed in case of males, whereas in case of females, the edges are thinner and round. Anal fin ray, thinner, whereas in case of female, thicker. Body shape, thinner, longer and symmetrical from the top. Fatter, shorter and asymmetrical from the top is the characteristic of the female, and that we know because of the maturity and having large number of eggs. During the onset of breeding season, male and female move in a pair. Male taking a position below the posterior region of a female with its snout nearer to the vent of the female and trunk below the caudal fin. Sometimes this courtship continues for several hours or even days. There are many researchers who have got, the entire courtship behavior or entire spawning behavior, videographed, and you can have a look if you get the information on the internet. So the pairs show such kind of courtship behavior. Then the female releases the eggs, and there should be synchronized release of milk by the female goldfish same time as the gametes from the male. Female is released, male also releases its gametes. Most of the eggs being sticky in nature, substratum may be provided in the form of soft aquatic weeds, tiles, corals, etc. for settlement and collection of the eggs for incubation and hatching. This is very important. At some point in some of my lecture, I discussed about that there are two broader categories of the eggs based on whether they are sticky or non-sticky. So if the eggs are sticky, then you will have to provide some kind of surface within the tank so as these sticky eggs are attached to some surface and they are not destroyed. They do not make a stack over each other. So so any kind of maybe natural some natural twigs or aquatic weeds or something you can take, or you can have some. There are many such kind of substratum available made up of some nylon or plastic linings or anything that can provide a substrate for the eggs to attach, to stick to. As the parent fish has the habit of eating its own eggs, that is one of the big problems, it is advisable to separate the egg collectors, the surface of attachment that you have provided for the sticky eggs. They are also known as egg collectors, containing eggs into a different incubation and hatching container. So as soon as you receive the eggs on the egg collectors, then remove the egg collectors from the tank where parents or brood fishes are there. So then remove those egg collectors. Each healthy and mature female may release about 2,500 to 3,000 eggs depending on the size and the stage of maturity and the condition. The goldfish may breed multiple times in a year. So 3 times, 4 times, it depends on how the cycle goes on. Fertilized eggs are transparent in color and unfertilized eggs are cloudy. Fertilized eggs are transparent, shiny, and they look very lively. And the unfertilized eggs are, apparently very dull, so cloudy. And as soon as you start noticing this, you have to separate the fertilized eggs from the unfertilized. Otherwise, all the fertilized eggs will be lost by fungal infection or any other microbial attack. Fungus grows very quickly on the surface of unfertilized eggs, and very often the infection spreads to healthy fertilized eggs too. Therefore, it is advisable to remove the unfertilized eggs as soon as possible once the egg laying is over. This is how egg collector, here plastic strips have been used, and then you can remove those egg collectors. When you are putting in the egg collectors in the tank, try to spread all it all through the tank, so as wherever the sticky eggs come, they get a substrate to stick to. Fertilized eggs hatch in 2 to 4 days depending on water temperature. In fact, hatching is strongly influenced by temperature. So at lower temperature, within the whatever range your particular fish species is having for hatching, within that optimal range of the temperature, if the water temperature is at lower level, then there will be hatching period will be extended. And if water temperature within that optimal range goes to the upper level, then the hatching time will be decreased. So that depends on the temperature variation. After hatching, the egg collectors are removed carefully so as to avoid the mortality of newly hatched larvae. And this is how hatchery produced goldfish fry they look like. Larval rearing, the newly hatched larvae depend upon their yolk sac as food source. We all know that they have natural food source in the form of yolk sac attached for a couple of days, and they do not require any external food during that point of time. So they will depend for their nutrition on the attached yolk sac only. The larvae start feeding after the yolk sac is absorbed. This is very critical stage. I told you earlier also that as soon as the yolk sac absorbs, the larvae will look for the exogenous feeding or external feeding from the external source. At that point of time, they are going to feed in the environment for the first time. So at that point of time, the food should be palatable, of the size which they can consume, and it should be readily and easily accessible to the larvae within the tank, and it should be easily digestible so that these fry do not die. So all these things should be kept into the mind. From the 3rd day onwards to 7th day of hatching, the mixed green algae are to be fed, followed by infusoria for next 7 days. So at that point need to be monitored very carefully, that you should be well aware that at what point of time yolk sac is going to be absorbed. You will have to add the food from that point only, but there is one very important point. You will also have to monitor the water quality. It's not like you have provided food earlier, in advance, and that is deteriorating the water quality. So they are not dying because of hunger, but they are dying because of the deteriorating water quality. So you will have to balance all this. In 3rd week, the fry are to be supplemented with boiled egg yolk and microworms. You can have your options. From 4th week onwards, Daphnia, Moina, tubifex are provided till it attains 10 to 15 millimeter length. Sometimes cannibalism occurs among the young fish also, if there is much difference in their growth rates and they are not provided with sufficient food materials. Any fish where there is any report of cannibalism, try to not stock varied fish size groups into one tank. So try to differentiate size grading. Size grading can be done within that species. Therefore, only the fish of similar size should be kept together in a nursery tank. Care must be taken to avoid the overcrowding of fish in larval rearing tank. After 1 month, the fry can be transferred to grow out outdoor tanks and fed with prepared pelleted feed containing 30% crude protein and 4 kilocalorie per gram gross energy till it attains the marketable size. So after this critical period is over, you can take them to the grow out tanks and rear them, culture them, and from there you can transport or sell it to the other ornamental fish culturists. So these are some of the photographs showing tanks and other things. Optimum levels of water quality parameters required for ornamental fish culture. That is a generalized parameter for freshwater ornamental fishes, but especially for the goldfish. Temperature 24 to 28 degree. In fact, in case of goldfish, you will have to keep it little lower, as we have discussed specifically for the goldfish in the previous slides. Oxygen never less than 5 milligram per liter, that has been discussed. pH 7 to 8, that is good. Hardness 150 to 200 ppm. Ammonia only trace amounts, nitrate only trace amounts, CO2 less than 15 ppm. So, whenever we are doing any culture practice, there are chances of disease occurrence. So, what we should do in order to avoid the disease occurrence, how we can manage that? Aquarium fishes develop diseases due to poor environmental condition. Preventing disease is much more economical, we all know. Prevention is better than cure, we all know. So, what are different steps that we can take? Provide adequate and non-polluted water. Water, since water is the environment where they are living, so that is everything to them. So, you will have to take care of the quality of the water that you are providing, whether the water quality is matching the desired requirement of the fishes you are culturing in that water. So, that should be taken care of. All the parameters that we have already discussed in our previous lectures and previous slides. Provide sufficient space. You should not increase stocking density to such a level that stress becomes unmanageable, and that stress will ultimately lead to disease occurrence. Provide adequate and balanced feed. Providing balanced diet is one of the most important aspects, because healthy and fishes receiving nutritionally balanced diet are less prone to disease occurrence compared to fishes otherwise. Intermittently clean and disinfect the system. That is again very important, especially if you are using the tanks which are not natural. You are using different materials to prepare the tank. So, you will have to clean and disinfect the system thoroughly, periodically or intermittently. You will have to do it. Always maintain compatible species. It's not advisable to keep together two fishes which may harm each other. For example, if you are keeping one predator with one very small minnow or a species which is herbivorous, so ultimately what will happen? One will kill the other. So, by understanding the biology and behavior of the species, you will have to choose the appropriate species for keeping in one tank. Avoid unnecessary handling. You can observe it from outside, but unnecessarily disturbing these fishes within the tank is not recommended. Separate the infected fishes. Whenever you notice any fish which is showing abnormal behavior, and if you believe that they may be carrying some kind of infection, or if you notice some kind of infection, immediately put them in quarantine, separate them and keep them in separate tank, and then you can take care of those diseased fishes or stressed fishes. When they are normal, again transfer them into the same tank. Provide adequate nursing for the diseased fish. These are some of the disease symptoms and possible treatments. You can have some but other options also. Like if you notice pinhead size white spots on the body and fins, that may be because of the protozoan parasite, and then increase the temperature and treat with 5% methylene blue, 1 drop per liter. Treat the fish for 1 week, you may get better result. White spot smaller than what has been described above because of the ichthyophthirius. Here you can, this is basically because of oodinium. Here you can use copper sulfate 0.1 milligram per liter for 10 to 15 minutes. Bath treatment you will have to give. Then white clumps with cotton-like appearance. This may be because of saprolegniasis, because of the saprolegnia. 1 teaspoon salt per 2 liters of water, 1 to 2 drops of 5% methylene blue or malachite green, or 2 milligram per liter for 30-minute dip, or 0.1 milligram per liter for permanent bath, that you can adjust. Swollen eyes, that may be because of the bacteria, virus or fungus infection, or sometimes together. 1% silver nitrate on popped eyes followed by 1% potassium permanganate. Then gradual disintegration of fins, if you notice, that may be because of the bacteria. Surgical removal of right portion by a fine sterilized scissors. Paint the cut wounded portion by iodine solution. Repeat the same at 12 and 24 hours. This is just an advice. If it works, then it's all right. Opercula is sticking out. Unusual swimming, tiny flukes on the gills, then that may be because of one parasite, Gyrodactylus. Formaldehyde treatment of 5 to 6 drops per liter can be given. Now, come to very quickly culture method of marine ornamental fish species. Culture method of marine ornamental fish species. So, here also we can take example of one marine ornamental fish species which is very popular, and we all know that marine fishes are in great demand in aquarium industry these days, and there are many species for which breeding has already been standardized and hatchery production of many marine fishes is being done worldwide. The marine ornamental fishes belonging to family Pomacentridae are the most popular group, accounting for 43% of all the fish traded, followed by species belonging to Pomacanthidae, then Acanthuridae, Labyrinidae, and so on. Gobiidae, Chaetodontidae, Callionymidae, then Microdesmidae, Serranidae, and Balanidae. Supply of fishes to the marine ornamental trade is from wild collection as well as hatchery production, but wild collection is dominating the supply. The contribution of hatchery produced fishes in the global trade of marine ornamentals is very minimal, which is less than 10%. There are currently 338 marine ornamental fish species belonging to 37 families reported as captive bred species. 37. But from this, only 24 species are regularly available in the trade. So, there is a lot of scope in hatchery production, standardization and production technologies, creating SOPs for hatchery production of marine ornamental fishes. The marine ornamental fishes that are most commonly bred in captivity include clownfishes and damsel fishes. They are very popular and important. India is a repository of more than 200 varieties of marine ornamental fishes, of which more than 50 are very bright and have export potential. Among these, clownfishes, or which are also known as anemone fishes, belonging to Pomacentridae, comprising of genera Amphiprion and Permanas, are most popular due to their beautiful color and hardiness and market value. Captive breeding of clownfish, taking clownfish as an example, Amphiprion percula. Here, first go for how we can breed them in captivity. In the wild, the clownfishes generally occupy in social groups centered in a host sea anemone with a sexually active pair of adults and 1 to 3 juveniles or sub-adult fish. Understanding the biology and behavior of this fish is very essential if we are desiring to have hatchery production of this fish. The clownfishes show monogamous pair formation, and these pairs need to be collected for broodstock development and breeding program. In case such pairs are not available, the fishes having different size groups can be collected and made to pair under captive condition, but that is not so easy. You will have to provide the conditions, the environment. Only then proper pairing will occur, which can be used for breeding. In order to make breeding pairs from the juveniles, many social groups of clownfishes can be collected from the wild and transported to the laboratory in live condition. During transportation, the fishes and sea anemones should be kept in separate plastic transportation bags. How the pair formation can be done, how it occurs. For the pair formation, 5 fishes of each sex of different size groups need to be stocked together along with single host sea anemone in a 500-liter tank fitted with biological filter to reduce the aggression. So, provide all the conditions, water quality conditions, environmental conditions that they need, and put not only these fishes, clownfishes, but also the sea anemone. The pair formation tanks need to maintain in the hatchery where an incident light intensity of 2500 to 3000 lux is available, as the sea anemones require sunlight for its better survival under laboratory conditions. Fishes and anemones should be fed 2 times per day with wet feeds such as meat of shrimp, mussel, clam at the rate of 15% of their body weight, and live feeds like Brachiones plicatilis, Artemia nopli, and adult Artemia. Environmental parameters such as temperature 26 to 29 degrees centigrade, salinity 33 to 35 ppt, dissolved oxygen 4.6 to 6.2 milligram per liter ppm, and pH 8.1 to 8.4 need to be maintained in all the rearing tanks. Sex change and pairing, if you already know about these clownfishes, they show very interesting behavior. Protandrous, they are protandrous sequential hermaphrodites. What does that mean? You will see. Male first. A pecking order is established in which the female is dominant, the male is subordinate and to the female, and all the other juveniles are subordinate to the adult male and female. The male and female form a monogamous pair bond that lasts until one member of the pair dies. If the female dies first, then what will happen? The largest male rapidly changes sex into a female, and the second largest or dominant juvenile takes the role of a male. Active male, it will become active male, and it pairs up with the newly transformed female. By utilizing this adaptation, pairs of clownfishes can be developed under captive conditions through creating social systems. So, by creating social systems, you can create number of pairs whatever you need, and after pairing is done, you can transfer the pairs into the other tanks. After a period of 3 to 4 months rearing in the pair formation, in each tank, one pair grew ahead of others and became the spawning pair. That is the kind of behavior they show. Tank setup for broodstock. A clownfish broodstock or a spawning tank should be 250 to 500 liter capacity with single healthy pair and host sea anemone. An ideal tank would be 3 by 2 by 2 feet with a layer of coral sand at the bottom, a few live rocks, bright lighting and good filtration, preferably an efficient protein skimmer to reduce the ammonia and organic material from the fish. Filter should also be used for regular water changes should also be done, taking care of the organic load, the oxygen supply and other things. Since the gonad development and spawning of clownfish are influenced by moon phases, the broodstocks or spawning tanks need to be kept in appropriate place where the fish receive a regular day-night lighting cycle, moon phase, or you can manipulate the conditions in the confined environment. An anemone is generally not required to breed clownfish under captive condition, but generally the clownfish select a nest site adjacent. That is why I was telling you, you should understand the behavior to the sea anemone for the deposition of the eggs. Moreover, an added benefit of having an anemone is that it may release compounds that help to protect the eggs or even chemically induce immunity that clownfish have with the anemone. Broodstock development and maintenance. The pairs formed through pair formation should then be transferred to separate glass aquaria for broodstock development. The broodstock need to be fed with wet feeds such as meat of green mussel, shrimp and clam that we have talked about earlier also, fish egg mass, and can also be provided formulated feeds enriched with vitamins, minerals and algal powder at the rate of 10% of their body weight. So, whenever you are providing any food from outside, you will have to take care that it should be nutritionally balanced according to the nutrient requirement of that fish species. Apart from these, the broodstock can also be fed with enriched rotifer 800 to 1000 numbers per ml and Artemia nopli 200 to 400 numbers per ml and adult Artemia 3 to 5 numbers per ml every day. Water quality maintenance. To maintain the high water quality or water quality parameters, it is the critical factor, which is the critical factor for breeding of clownfish or any marine fish or any other fish under controlled condition, I should say. As a measure for this, the seawater need to be filtered through a series of sand filters before being taken for to the rearing tanks. So, that is always water quality. I have always talked about this, that water quality is something which is very important, which is in fact starting of your culture practice. So, whatever stage you are doing, the temperature is in all the breeding tanks need to be maintained between 26 to 30 degrees centigrade for clownfish, and level of DO 4.8 to 6.3 ml. In fact, it should never come below 5 ppm, just make it a rule. So, everything will be fine. Salinity 30 to 35 ppt. Once in a week, at least 1/4 of the water may be exchanged. Egg deposition. Few days prior to spawning, the male selected a suitable site near to sea anemone for laying the egg and starts clearing the algae and debris with its mouth. And on the day of spawning, both the parents spend a lot of time for cleaning this site where the eggs are to be deposited. Then if these things you notice, then be prepared that now spawning is going to occur. The clownfish have attached eggs and are known to spawn on rough surface substrata near the host sea anemone. If you have this idea, then what you can do, it is essential, it is written here, it is essential, or you can say it is advisable, it is desirable to provide suitable substratum, preferably tiles or earthen pots or shells of edible oysters or PVC pipes for the egg deposition, but try to provide such material which are not having sharp edges that may damage your tank or the eggs in the process. Each female lays 300 to 1000 capsule shaped eggs at every 12 to 15 days interval, depending on the species of clownfish, size of the fish and previous experience. Generally, the egg size of clownfishes ranges between 1.5 millimeter to 3 millimeter in length, with a width of 0.8 to 1.84 millimeter and adhere to the provided substratum with the stock. An average of 2 spawning per lunar month per pair, resulting in an estimated annual fecundity of 7,200 to 24,000 eggs per breeding pair per year can be obtained under laboratory conditions, or with more manipulations, with more laboratory setups, you can have maybe better outcome. Parental care. As parental care is inevitable for hatching out of the larvae, the parents should be allowed to remain in the parental tank itself till hatching. That is important. In case of goldfish, you are not keeping the parents in the tank where eggs are released. But here, we are keeping the parent. That's what is the difference between the biology and behavior of different fish species. During incubation period, both the parents carefully look after the eggs during daytime, and it involved 2 basic activities: fanning by fluttering the pectoral fins and mouthing to remove the dead or weakened eggs and dust particles. The newly spawned eggs were white to bright orange in color for initial 2 days, and the embryo developed. These were turned to black on third to 6th day, and later turned to silvery color of the larvae's large eyes on 7th to 8th day of incubation. At this stage, the glowing eyes of the developing larvae inside the egg capsule can very easily be seen. Male assumed nearly all responsibility of caring for the eggs and spent a higher percentage of time at the nest than the females, which increased gradually up to 70% of time as the day of hatching approached. When incubated at a water temperature range of 27 to 29 degrees centigrade, the hatching may take place on 8th day of incubation, and peak hatching took place shortly after sunset. So, timing in case of these fishes, especially some marine fishes, that is again very important. Egg hatching and larval rearing. On the expected day of hatching, 2 hours before sunset, the eggs along with substratum were transferred from the parental tank to hatching tank and provided with complete darkness for accelerating the hatching. The newly hatched larvae measured 3 to 4 millimeter in length, and each had a transparent body, large eyes, visible mouth and a small yolk sac, and remained at the bottom of the tank for a few seconds, and soon after they became free swimming. The larval rearing can be carried out under green water system that we talked about earlier, feeding with super small rotifer B. Rotundiformis and newly hatched Artemia nopli. The larval period of clownfishes generally lasts for maximum of 20 days, and then after most of the fry resembled juvenile adult fish and began to shift from partially pelagic to epibenthic and started eating minced shrimp, fish flesh, mussel meat, clam meat and formulated diets. Larval feeding. As the mouth gape of clownfishes fish larvae is between 80 to 123 micron, the larvae need to be fed live food which is smaller than its mouth gape. All the rearing tanks need to be provided 24 hours light up to 15 days of post hatching time. During this time, the larval tank must be kept very clean with the bottom siphoned off dead larvae, detritus and feces twice a day. Water changes will also need to be performed at a rate of at least, we have talked earlier also, at least 1/4 of the water per day. Feeding schedule of larvae of clownfishes can be performed in 2 stages. Stage 1 covers the rotifer with algae feeding phase from day 1 to 8th. Stage 2, the newly hatched Artemia and rotifer with algae feeding phase from 9th to 20th days. The clownfishes have larval period between 10 to 20 days. After 20 days of rearing, the larvae develop into the adult striped coloration and metamorphose to juveniles and shift from partially pelagic to epibenthic. Larval rearing, the maintenance of high water quality is possible, possibly the critical factor when larval rearing of clownfish is done. As a measure of this, seawater need to be, I think this slide, I have repeated some information in this slide that can be removed. We can skip this slide. Now come to juvenile rearing. At this stage, stocking density need to be reduced to 90 to 100 numbers of juveniles. Size range between 8 to 10 millimeter with single host sea anemone in glass tank at 100-liter capacity for initial 1 to 2 months rearing. During juvenile stages, the fishes show different banding pattern and growth rate, and on attaining size of 24 to 35 millimeter in total length, the stocking density need to be reduced to 30 to 35 number with single anemone in 100-liter tank with 80 liter of biofiltered seawater until marketing. So, as they will continue growing in size, we will have to periodically reduce the stocking density as well. In the case of each 500-liter tank, 130 to 150 juveniles can be reared with 1 to 3 sea anemones. In the juvenile rearing, survival rate of 100% can be obtained through feeding with different wet feeds, mussel meat, prawn mussel, fish eggs and minced flesh of trash fish at the rate of 15 to 20% of the body weight. That gives quite good result. Apart from the, but whenever you are feeding with live feed or wet feed, taking care of the environment or water quality is of utmost importance. That should be taken care of in a very alert manner. Otherwise, the things go out of the way. You will not be able to control then if water deterioration occurs. Apart from these, Artemia nopli 10 to 15 numbers per ml and rotifer 50 to 55 number per ml were given after enrichment with brown algae 104 cells per milliliter and green algae 106 cells per milliliter with cod liver oil and fat soluble vitamin A, D, E, K twice a day, which help to retain the color of the fishes and provided adult Artemia 2 to 4 numbers per ml. Through this feeding schedule, the larvae will attain 10 to 12 millimeter within 30 days of post hatch, and the juveniles reaches 25 millimeter to 35 millimeter within 60 days and reaches marketable size within 6 months after post hatch. Now, if you are successful in doing the rearing up to this stage, then we can go for packing and transport, marketing of our fishes. These fishes, when we have to pack them and transport them, market them, then they are starved for about 2 to 3 days before being transported. A small amount of fresh water is added to the packing water and chemicals may be added to tranquilize for longer journeys. Packing starts just prior to the transportation. Fishes are packed with oxygen and a little water either singly in double polythene bags to ensure that fish are not stranded without water. Polythene bags are packed in cardboard boxes for short journeys, and for long journeys they are packed in styrofoam boxes with some ice to keep the temperature down. Depending on the conditions, I have already explained you about how fish seeds are packed and transported to different regions. So we have to take care of their oxygen supply, the temperature conditions, the salinity conditions. Taking care of everything, we should be extra careful in especially in temperature and dissolved oxygen. So these things should be kept in mind before um, packing and transporting these fishes. That's all in this lecture. Thank you so much.